If a plant has enough water, minerals and energy, it will grow, right? Well, sort of. But there is more to it, like why do plants bend towards the light and not just grow straight? And why is it that the stem grows up but the roots grow down? It isn't as if the plant has eyes to tell it where the sun is. You should already know about tropisms, so phototropism and geotropism. But if you have forgotten, watch our video called Plant Hormones, Tropisms, first. But how does it actually do this? Having been made in the tips of the stems and roots, auxin is moved in solution by diffusion to older parts of the plant. In the stem, the auxin causes the cells to change in elasticity. More elastic cells absorb more water and can grow longer. Strangely though, stems and roots respond differently to high concentrations of auxin. Whilst the stem cells grow more, the root cells actually grow less. So auxins make plants grow. But why do they bend towards the light? How do they know to do this when they don't have eyes? The bending happens because the light hits on one side more and breaks down the auxins on that side of the stem. So then growth slows down on the light side. The faster growth on the dark side causes the shoots and leaves to turn towards the light, which is ideal for the plant for photosynthesis. Auxin is produced in the tips of growing shoots. If the tips are cut off, then no auxin can be produced and so no plant growth. If the tips are covered whilst auxin is still produced, light cannot break it down and so phototropism cannot occur. The plant just grows straight up and does not bend towards the light. Pretty straightforward so far. Now let's switch it up a bit. Auxins have the opposite effect on root cells. In roots, auxins cause less growth. The shaded side of roots contain more auxin, and so they grow less. This enables the light side of the roots to grow more and bend away from the light. And if that wasn't weird enough, we have the opposite happening with auxins to gravity too. In a horizontal root, the bottom side contains more auxin and grows less. So the root bends downwards in the direction of gravity. So positive geotropism. But of course, the stem responds differently. In a horizontal stem, again, the bottom side contains more auxins because it is less directly hit by sunlight. But because auxins cause growth in stems, the bottom side grows more, causing the stem to bend upwards, against the direction of gravity. So, negative geotropism. But I'm giving auxins too much credit. They don't work alone. They have a partner in crime. Cytokinins. You don't need to know anything about these hormones, other than the fact that they work alongside auxins. There is another plant hormone, however, that you do need to be aware of. Gibberellins. Once a seed germinates, the roots and shoots start to grow. But for this, the seed needs energy. Luckily, the seed releases a hormone called gibberellin, which causes the starch in the seed to turn into sugars and provides the seed with energy to grow. As well as causing shoot growth, gibberellins can also stimulate flowering and the production of fruit in some plants, and they also work with auxins to cause stem elongation. So now we know all about how plant hormones work. Have a think about how they could be used. We will discover some uses in our video on how we use plant hormones.